When you encounter a radical expression that's really complicated and it's really not clear how to simplify it, there's a trick, and that trick is to use rational exponents. Rational exponents, right? Here's how you do it. The 10th root of a to the 5th b to the 5th is the same thing as saying a to the 5th b to the 5th to the power of 10, 1/10, 1/10, right? Because a 1/10 power is the same thing as a 10th root. Okay, now we can use the rules of exponents, right? We distribute this through to both of these and then multiply. So the 1/10 goes through to the 5th and the 5th, and then we multiply. That gives us a to the 5/10, b to the 5/10, 5/10. Simplify gives a to the 1/2, b to the 1/2. But here's the thing, if you're given an exercise in radical form, it's only fair to return an answer in radical form. So here, let's keep going with this. We can see that these are going to be square roots. Let's go even further. AB to the 1/2, which is then square root of AB. That's the simplified form that we're looking for. So it's a powerful approach to switch to rational exponents. Let's try B. We have cubed root of y squared times 6th root of y. Upon first glance, it's hard to tell how these radical expressions would simplify. Remember that mth root of a to the n is the same thing as a to the power of n over m, right? That's our key that we're using for this, right? So this one here, we have, okay, we'll write this as y to the 2/3 power times y to the 1/6 power. Okay, well now we have the same base, so we use our rules of exponents. That tells us to add the exponents together. So y to the 2/3 plus 1/6. Okay, well now we need a common denominator. I'm thinking a 6 will do the trick, so I'm going to multiply that first one by 2 over 2. That gives us y to the 4 plus 1 all over 6, y to the 5/6. However, since we were given the exercise in radical form, we need to return the answer in radical form. All right, so we can do that. This is simply the 6th root of y to the 5th, using the same principle up here. Let's look at C. Same idea. We have 4th root of a divided by the 5th root of a. First, we convert to rational exponents. So this is a to the 1/4 over a to the 1/5. Since these are the same base, the rules of exponents tell us to then subtract the bottom from the top. This gives 1/4 minus 1/5. We're going to need a common denominator here. We have 4 and 5, so 20 is going to be our LCD. So we're going to multiply by 5 over 5 on the left side, 4 over 4 on the right side. That gives us a to the 5 minus 4 all over 20, which is a to the 1 over 20. Again, they gave us a question in radical form. We need to return an answer in radical form. So this is 20th root of a. And this answer is not even remotely clear without converting it into this rational exponent form. So it's a very useful technique.